Hello, and welcome to the presentation of the new ASAM XIL compliant signal generator feature, which lets you stimulate your model using ASAM XIL standard signal sequences. ASAM XIL is an API standard for the communication between test automation tools and test benches. The standard supports test benches at all stages of the development and testing process, most prominently model in the loop, software in the loop, and hardware in the loop. The notation XIL indicates that the standard can be used for all in-the-loop systems. Typhoon XIL software supports the model access port from the ASAM XIL standard. This port specifies the necessary functions required for accessing and controlling XIL simulations, including read-write functionalities, simulation control functions, and capture functionalities. The current implementation of the ASAM XIL standard within the Typhoon XIL toolchain uses the C# programming language. Until now, Typhoon XIL Control Center supported only basic functions for configuring the model access port and capture functionality. From the 2022.1 version of the software, a new set of signal stimulation functions has been added to the list of ASAM XIL supported functions. These functions are shown here. These functions use the Dynamic Model Stimulation feature in XIL API. Dynamic Model Stimulation is a set of functions that enable reproduction of high-resolution time series profiles during simulation runtime. Now, let's look at the interaction between Typhoon XIL Control Center and one of the standard ECU test tools that supports the ASAM XIL standard, Tracetronic ECU Test. Using this tool, different test cases can be created for automotive software. The testing process can be easily automatized. To demonstrate signal stimulation from ECU test, let's use a modified dynamic model stimulation example. Let's look at this part of the model in more detail. The model consists of a grid and residential load, a charging station, and an electric vehicle. The reference speed of the electric vehicle will be the signal provided by the signal stimulus from ECU test. For this purpose, we will use the SCADA input speed as the signal stimulation component in Typhoon XIL schematic editor. Signal streaming probes are used for monitoring signals from the plant model. Now, let's move over to the ECU test tool. Here we can look at the test structure in detail. The test structure consists of setting the signal stimulation, starting the trace for monitoring the data of interest, and generating the report and observing the trace analysis. Before we run the test, let's add the signal stimulus. To do that, we need to add the start and stop stimulation from the Test Steps tab. Here we need to add the .stz file. The stz file is used for configuring the stimulation signal. To have a better insight into the test as it runs, we will use XIL SCADA debug mode. Using this mode, you can connect to a model run by ECU test or any other tool which utilizes XIL API. Let's run a test from the ECU test software. In the package progress window, you can see the progress of the cycle test. Now let's look at the trace graph in XIL SCADA, and specifically the measured speed and reference speed. The speed of the electric vehicle is following the reference speed, as we can see here. Meanwhile, here we can see that we managed to run signal stimulation from ECU test successfully. Finally, let's take a look at the test report. We can see that this test failed. To conclude, from the 2022.1 version of the software, Typhoon XIL supports additional functionalities for the ASAM XIL standard. Signal stimulation functions are added to the list of ASAM XIL compatible functions, meaning integrating your existing testing framework is easier than ever. Thank you for watching.